Hello and welcome, everyone. My name is Julie Noblet. I'm Community Manager at the Diagram Center at Benetech in Palo Alto, California. You have tuned in to see our newest webinar, New Models for Creating Accessible Interactive Widgets for STEM Learning. So let me start by telling you what you have in store for you today, and it's really a treat. We have two presenters, Kyle Keane, research programmer at Wolfram Research, and Madeleine Rothberg, project director at WGBH, National Center for Accessible Media. Kyle is going to begin by going over the research that he did for Diagram to survey the most effective practices for making interactive scientific graphics accessible to those with visual impairments. He's going to tell you about the results of that research, and he's going to show you the working example he developed. After that, Madeleine will go on to show us other examples of interactives available from the likes of Pearson and point us to guidelines and emerging standards in this area. But before we get started, I just want to say a quick word in case Diagram is unfamiliar to you. We are an R&D project that is part of a global literacy initiative of Benetech, which is a nonprofit social enterprise based in Palo Alto, California. And our goal, we have a laser focus on images. We want to make it easier, faster, cheaper to create and use accessible images for students with print disabilities. Before we jump into the exciting content, I have just a couple of housekeeping items for you. First of all, if you are just dialing into this webinar and can't see the slides going by on ReadyTalk, you can download slides, both a PowerPoint version and then a Word version equivalent at the URL on the screen, diagramcenter.org/webinars.html. This webinar is being recorded, and it will be available to everyone at in just a few days, sometime next week. The webinar is also being live captioned. And if you want to take advantage of that, open the second window, the live captioning window at the URL that I've provided both here on the slide and in the chat window. Now, for the best audio quality, since we have quite a few participants on the line, you are all muted, so you can hear us, but we can't hear you. But we welcome your questions. We want your questions. Please enter them in the chat window. We will collect them throughout the webinar, and then we will have a Q&A period at the end to take care of all of your questions. So, with no further ado, let me turn the mic over to our first presenter, Kyle Keane. Kyle?
Thank you, Julie. Yes, so I will talk about three quick things. I mean, maybe quick, maybe long. Myself and the project that we did, the report that was published, and the working example that is open source on the web to help people understand the results in the report. So my name is Kyle Keane. I am a research programmer at Wolfram Research, and all of the materials that were produced during my project can be found at the URL that's on the screen. That is diagram-center.org/accessible-dynamic-graphic.html. So I encourage you to go download the report and play with the working example either now or later, either way. Okay, so the first thing I'm going to talk about is this update. I see, Madeleine, can you drag my slides? It doesn't seem to let me Oh, there we go. Okay. So the first thing I'm going to talk about is the content that I was looking at in this project. We were looking at widgets, which is a buzzword which I think can best be summed up in a very general statement. A widget is a digital representation of information that allows interactions from a user to change the information or display of the information. Essentially, everything on a computer is a widget. But an example of a widget is a circle that is connected to radio buttons that allow you to change the radius of the circle. And when you choose another radio button, the circle radius changes in real time, and you can see the effects of your interaction. So to become more specific in scope, so that we could do something truly helpful, we focused on interactive scientific graphics in this project, which are just widgets used for STEM education and communication, which just means the information being displayed is usually a data visualization, like a chart or a plot or a graph, some kind of scientific information that's being communicated to the student. A very simple example of an interactive scientific graphic. There's a picture on the screen. It is a slider control that allows somebody to change the number of dogs from 0 to 200. And what that will do is below the slider is a graphic that's titled Pets, and it has two bars. One bar is dogs, one bar is cats. And if you change the number of dogs slider, then you see the bar inside of the graphic change. This is a very simple example, and it was done very simply so that we could get to the root of the user interactions and the user interface and try to actually break down the process of somebody trying to use an interactive scientific graphic. I'm waiting for my slides to progress. I'm sorry, for some reason my slide has frozen. All right, here we go. Okay, so an overview of what was produced during the project, and I will talk about them in high-level terms during this webinar, is a written report. In the written report, we systematically analyzed the interaction stages of somebody trying to use an interactive graphic, and I'll introduce those stages in a slide in the future. Identify the different components of a widget, what makes a widget a widget. And the second thing that we produced is a working example, which I'll talk about in the future. Okay, so the written report, which should be the slide that's showing on your screen, as I said, can be found at diagramcenter.org/accessible dynamic scientific graphics.html. It's about a 50-page report, and it has a lot of the research methodology explicitly spelled out, as well as a huge list of resources. The appendices are about 11 pages, and a lot of that is information, links to other reports, links to all sorts of things that I could find about accessibility of interactive scientific graphics. And again, I'm sorry, my slides seem to be very delayed in transitions.
is Madeleine. I was able to advance your slide. It seems like the slowness is on getting them on your screen, so why don't you go ahead and keep talking and just let me know when you'd like me to swap the slides.
Oh, okay, perfect. Thank you so much. So right now we are on which slide? The summary?
That's right.
Okay, perfect. Thank you so much, Madeleine. Okay. Yeah, so the summary of what's inside of the report is we analyze the interaction stages. We look at the components of interactive widgets. We do a big review of literature about best practices for making each component accessible. And then we try to synthesize all of those reviewed best practices into some set of recommendations for best practices moving forward. Okay, next slide, please. Okay, so the first thing that we did is we broke down the interaction stages of somebody using a user interface, an interactive widget on a computer. The first stage is discovery, meaning you are exploring your computer screen and you discover something that is interactive, and you need to know some basic information like how many controls are available and how many linked graphics are there or other communication methods are there. The second stage is navigation. So once you've found this object, you now need to be able to move around it and find basic information, what type of information is there and what information specifically is there available for you. The third stage is selection. So now that you understand what information is there, you want to actually interact with your widget. So I call that the selection stage because then you're learning about what the current value for your control is and how that's affecting the information that's being presented. And then a fourth stage, which is on demand, which means real time at any point during your interaction, you need information accessible to you through some very quick way. So you need to know the basic information about what information is inside of this widget or how you're supposed to interact with it. How do you select things? How do you navigate? How do you discover more information? You need an on-demand information command. Next slide, please. So the second part of the synthesis was to break a widget down into its components because there aren't accessibility guidelines for interactive widgets yet, but we do have guidelines for static images, and we do have guidelines for moving images, and we do have guidelines for computer control objects, digital control objects like menus and radio buttons and checkboxes. So if you think of a widget as a display area and a control area, you can now start to draw on existing recommendations. Next slide, please. In the case of interactive scientific graphics, I just renamed these two areas. You have a dynamic scientific graphic, which is just a still or moving data visualization, and a digital control object, which is some standard computer control object like a radio button, a checkbox, a drop-down menu. Next slide, please. So we reviewed existing literature the best we could. We found 5 main sources of information having to deal with just the information display, dynamic scientific graphics. There is information in Section 508. WebAIM has put out a lot of good information about making graphics and moving images more accessible. The W3C has HTML5 specifications that talk about making SVG graphics more accessible and other graphics accessible. NCAM has a specific report out about making scientific images more accessible. And then a lot of description and audio description guidelines exist. So we synthesized all those into a set of recommended best practices. Next slide, please. And I won't go through each of these, but here are the recommended Practices, you need to make sure that your content is accurate, equivalent, objective, and essential. You need to make sure that your vocabulary is contextual to the information being presented, common so that people understand what it is, and appropriate. You need to make sure that your phrasing is clear, concise, and understandable. You need to make sure that your delivery is apt, synchronous, meaning in real time, and controllable by the user. And if you want to know about more of the logic behind where these came from, go check out the report. I very clearly, I think, go through the process of, Section 508 has these recommendations, and we built them into ours in this way. Okay, next slide, please. Then we looked at the digital control objects, which again have existing standards with Section 508. Accessibility has to do with making sure widgets are keyboard navigable. WebAIM, again, has good literature about making computer interactions more accessible. The W3C, also in their HTML5 specifications, have to have recommendations for making checkboxes and radio buttons accessible. I would like to call out Indie UI, which is a great working group within the W3C, dealing with making user intention separate from the actual physical action of creating an interface object, making an interface object do something. So you should be able to communicate your intention rather than have to do a specific physical action. And then, of course, accessibility APIs for operating systems. They are sort of the bread and butter. They're the first thing that came out and said, if you're going to be building computer applications, you need to be making sure that your checkbox communicates its state and the information to the operating system so that we can tell assistive technology what information to give to the user. So all of these components have information about control objects. We synthesize that to a set of recommended best practices. Next slide, please. And we, lining them up with the 4 interaction stages, you have discovery, navigation, selection, and on-demand. And a lot of information should be on demand, but a lot of the other information that's important, like the identity, needs to be presented immediately when somebody discovers a digital control object. And again, the logic behind where each of these recommendations comes from and how they relate to the specific problem in interactive scientific graphics is explained in the report that's available for free on the website. Next slide, please. So the next main component, the next deliverable that came out of this project is a working example. On the following website, diagramcenter.org/accessible-slider.html. And feel free to go there right now and play with it. I'll also show a live video of it being played with. And on the web page, you'll find an overview of what functionality exists, instructions for using the working example. You'll find an interactive graphic that follows all of the recommendations of the written report. It's a very simple interactive graphic. It's the standard slider with some added hotkeys and then a simple bar chart that displays whatever the current data is from the slider. And then a speech log, which is there. This working example will it speaks with assistive technology, so it hooks in through ARIA live rules and allows a user to use a screen reader to explore it, but it also has a visual speech log that Cited developers can use to see what messages should be spoken when, as well as allows navigation for blind users to look through the list of messages to see what was happening when they were doing what. Next slide, please. So here is the picture of the working example. It's that same interactive graphic that I showed before with a slider that controls the number of dogs, and then 2 bars in a bar chart. One of them has to do with the number of dogs, the other has to do with the number of cats. That's the interactive graphic. On the right-hand side of the screen is the speech log, and it also has a list of the hotkeys that are built in to that slider into that interactive graphic to allow users to access information when they need it. Next slide, please. And for the developers out there who are interested in how this was made, it's a very simple, I believe, shareable, extendable example. The slider is standard HTML5, which gives us access to the keyboard control that already exists. It gives us access to state, which is communicated on Discovery already. I think that accessible things need to be built from existing standards, and then we can demonstrate what new standards we wish by adding to them. So it's a standard HTML5 input, and then there's added JavaScript functions that allow hotkeys to interact with the actual display of information with the bar chart. So on key up, on key down, on mouse down, and on focus allow the bar chart to be updated. And the bar chart is done with standard SVG, and it's updated by JavaScript from the slider. And the speech log is just a standard list. And part of this slider's function is it adds messages to the speech log, and then ARIA Live tells assistive technology to speak those messages. So the next thing will be a video of this example being used live. So if you could play that, Madeleine. Thank you. Play that, Madeleine.
Here we are on the interactive graphic. For right now, just pay attention to the left-hand side where I'm moving the slider with the mouse, which is changing the bar chart dynamically. Pressing the X key will clear the speech log, and then we can hold down the right or left arrow keys, which will change the value of the slider, which is standard HTML5 behavior. However, there is an additional JavaScript function which is updating the graphic every time the value changes of the slider. Pressing the X key again will clear the speech log, and now we can press the U key, which will bring up a list of the other hotkeys that are available for this interactive graphic. For example, pressing the F key will tell you the function of the control object that you're on, the slider, and pressing the O key will give you an overview of what that slider's function is. We can also press the D key, which will give us a description of the current graphic using the values that are presently inside of it. Pressing X will clear the speech log again just for visual clarity. If we press I, we can change the increment value. So every time I press I, it toggles through a list of possible increments, which allows me to use the right and left arrow keys to quickly navigate through the slider values. We can press the X key to clear that speech log again. And now, if you press the V key and the C key, you'll learn information about the current value that you have selected and the change in the graphic that's happened after you've navigated with the right and left arrow keys. So press B, which will give you the value, and press C, which will give you the change in the graphic. Again, pressing X will clear the speech log for visual clarity. Now press the R key, which will toggle on and off real-time updating. When you've toggled off real-time updating, when you press the arrow keys, the graphic doesn't update until you press the S key for selection. And then you can use the V key to learn about what current value would be selected. When you press the S key, it selects it. When you press the C key, it gives you information about what has changed inside of the graphic.
that is the demo. Please go play with the graphic and send feedback. I want it to exist as a living document that shows people what functionality everybody wants in interactive graphics. And I did a lot of research to try to make sure that this represented the current state of affairs. But everybody here has a voice, and I would love for people to go break it, tell me what's wrong with it, tell us if there's something that should be handled better on a technical level. Any feedback is good feedback. And yeah, so that is my section. At this point, I will turn it over to Madeleine, and she can talk about some of the cool upcoming stuff that she's working on.
Thank you, Kyle. This is Julie. Before we move to Madeleine, we just had one or two questions here. And by the way, one comment in the chat field here, and it is in all caps for emphasis, and it says, "This is awesome." So I think resonated here a little bit. So one question is, can the interactive graphic be read by any screen reader?
Right now, it's described on the website. We tested it with Windows, JAWS, NVDA, Chrome, and Firefox, and that is definitely working. The only reason it wouldn't work with a screen reader is because the browser that you're using doesn't support ARIA roles. So any web browser that supports ARIA roles should absolutely work with the screen reader.
Okay, great. And, another question came in that the questioner acknowledged that you did answer in your comments, but I'm going to ask it anyway for the benefit of the crowd in case others have the same question. The question is the screen reader listing all the entries on the log, or does it have the ability to wait until the slider stops at a particular reading?
There are different, right now it is reading everything, but it's interrupting itself. So as you navigate through the slider and you see this like 40%, 41%, 41.5%, it's making noise, but as soon as a new message gets added to the speech log, it's interrupting. And that's a feature of ARIA Live. It's assertive, so it's just interrupting itself every time a message is spoken. With modifications to that, we could, put a delay that would wait until, the slider stops moving and then speak the full information about the slider. But it's a subtle problem that is discussed in the report as well, is how much information needs to be communicated while you're moving the slider and how much information needs to be communicated once you stop moving that slider.
Okay, and then just to follow up on that, the same person asked, so you had you tested with ARIA Polite? And again, this is so awesome. This is awesome.
Thank you. I tested with ARIA Polite. I'm not even sure. It might even be ARIA Rude right now because I didn't want it to, because if you do overly polite, it will just start reading its own. It'll start queuing up messages, I believe. I don't remember. I tried. My favorite functionality was when it was ARIA assertive or rude, because there's a lot of messages being spoken, and you definitely don't want them to get queued up inside of your computer. Otherwise, it'll be speaking for 40 years, which would be very bad.
Okay, and then one last question. You're making Sue Ann laugh here in the room. One last question before we move on to Madeleine. Did you look into presenting graphics of this type on mobile devices with screen readers, for example, iPad with VoiceOver, or is this more desktop focused?
There is some functionality. There are issues with ARIA support, but you can test the website if you go to it with on a mobile device. You can get some information back because you can interact with the HTML sliders. The problem is that there's no keyboard control, so being able to hook to another system of communicating alternate hotkeys was a development problem that we could look at in the future. But most of it works, other than there's no way to get hotkey messages to the slider on a mobile device right now.
Okay, thanks, Kyle. And there are more questions, but I think at this point I'm going to hold them to the end, so that we have a chance also to hear from Madeleine. So thank you, Kyle. And Madeleine, over to you.
Hi, everyone. I'm Madeleine Rothberg, and I'm a project director at the WGBH National Center for Accessible Media. And we are a partner in the Diagram Project, which means that we get to participate in a lot of terrific work that Diagram's doing, including this. So what I'd like to show you today is some really interesting work that's being done by Pearson. Pearson is a great big textbook publisher, and they're working hard on the accessibility of their output. They also participate in the Diagram Center because they're on the cutting edge, really, of what's going on in technology for education right now. And they have a new product coming out this fall. So this is not public yet, and I would like to say thank you to the folks at Pearson, and especially Elaine Ober, for giving us permission to have a sneak peek at these accessible interactives today. Pearson is launching a new line called Revel this fall, which is a new approach to interactive materials for higher education with lots of tools built in for students and teachers. And in doing so, they knew they needed to have a lot of accessible interactive widgets. They wanted interactivity, and they wanted it to be accessible. So they partnered with MetroDigi, which is a company that's creating a lot of terrific interactive educational materials, and with the SSB BART group for their accessibility expertise. And so I'm going to be able to show you today two of those widgets in use with a screen reader. The first one I'm going to show you is called the string problem. And it's an interactive that relies largely on visual information. The interaction itself is not too complex, but there's a lot going on the screen that you need to know if you can't see the screen. So it's a little bit difficult to demonstrate these live in a webinar. So as Kyle did, what I'm going to do is show you a video of me using the interactive and explaining what I'm doing. So during the video, I'm using VoiceOver for Mac as the screen reader, and the text that VoiceOver is speaking appears in a black box below the activity screen. So you'll hear my voice, and you'll hear VoiceOver. I hope that the audio will all be clear and that everyone will be able to hear who can hear it. Also, the resolution of the visuals in the video is not as good as it was natively on my own screen. So if you find that the on-screen text is a little bit fuzzy, I apologize. It is not the quality of the original resource. It's the quality of the video. So take a look, and let's see how this plays.
This is an interactive demo that relies on detailed graphics, and its interactions itself are fairly simple, but to properly convey all the content is where the accessibility is needed. So let's have a listen.
Man standing with arms outstretched to his sides, his right arm holding a string attached to the ceiling, his left arm reaching for a string hanging straight down from the ceiling. The string he is not holding is about 2 feet from his left hand. To his right is a table with the pliers on it. How could this man tie the two strings together if he can reach both at the same time? Click Next to see the solution. Group.
So pressing Tab to move to the next button.
Next button.
And selecting it.
You are currently on a group inside of a ring. To enter.
And now the image has changed, so to hear the new image, we'll move back to that.
Previous button. Image of same man holding a string attached to the ceiling in his right hand. The string hanging from the ceiling to his left is attached to the pliers and can swing to the point that it reaches the string in his right hand. Using the pliers as a pendulum, he can swing the second string close to him. Group.
So I hope you could hear that the detailed description gave an
You are
overview
currently
of
on
what
a
was on the
text
screen.
element inside of a
as well as giving the text that's on the screen. And together, those two enable a user to understand the full intent of the activity.
So that's the first demonstration, and I think it was a really successful approach using good, clear, concise, long description to convey what's going on in the screen so that everyone can understand it. The next example I want to show you is a little bit more interactive. It's a drag and drop activity. And for those of you who've been working in accessible technology for a long time, drag and drop is one of our big problems. It's a well-loved interaction mechanism. Mouse users can do it, generally speaking, with pretty good ease. And it's just very hard to adapt for the keyboard and very hard to adapt for a screen reader user because there's no spatial cues for where are you going with this thing and how will you know when you've gotten there. So I'm going to show you a video. The approach to accessible drag and drop here I think is pretty innovative. It kind of turns the whole thing upside down and turns it into a truly keyboard accessible activity. So let's watch that.
This activity...
Oh, I'm going to pause the video just for a moment to say that this second video is even less clear because the text on the screen was somewhat small, and in order to get it into the video, it makes it even smaller. So you don't need to be able to read all those tiny words on the screen. You should still be able to understand the activity.
Is an interactive table that includes a drag and drop interface, and it's called Gardner's 9 Intelligences. It's a table with 3 columns and 9 rows, and the goal of the activity is to first read through the table and then check your understanding by moving pieces back into place when they're removed from the table. So I'm first going to show you how this works from the mouse, and then I'll turn on a screen reader and show you how it works from the keyboard. So for a mouse user, they can read the screen using assistive technology if needed, and then select the button Check Your Understanding. When I select Check Your Understanding, the first column, the types of intelligence, is empty, and one of the entries for that column appears in a small draggable object at the bottom of the screen. So right now that says Visual Spatial. So if I take the Visual Spatial box and drop it in the wrong row, I get a message that says incorrect, try again, and the box pops back down to the bottom of the screen. And if using my mouse, if I pop that box into the right place next to ability to understand how objects are oriented in space, then Visual Spatial clicks into place, I get a correct message, and another box appears, movement, and now I can move movement into place in the correct row next to ability to control one's body motions. That clicks into place and the next one appears, and so on. But appearing in the upper right corner is a little symbol for accessibility, and when you choose that, it switches the mode of this interaction into a keyboard-oriented interaction. So let me first start over to clear the board and return to check my understanding. And now I'm going to start my screen reader and then begin the accessible mode.
VoiceOver on, Chrome, HT.
With VoiceOver on, I can now choose the accessibility button.
Visual Spatial.
And immediately I hear the first item that needs to be moved into place. It's Visual Spatial. So now using the keyboard, I can navigate through the choices.
Type of intelligence,
Type
group.
of intelligence, that's a row header, a column header.
Description, group.
Description header.
Sample occupation, group.
That's the header for the third column. And now as I move through, I have to decide which row does Visual Spatial belong in.
Row 1, ability to use language. Writers, speak.
No, ability to use language doesn't sound like Visual Spatial. Moving on.
Row 2, ability to compose and / or perform music. Musicians, even those who do not read musical notes but can perform and compose.
That's not the right one either.
Row 3, ability to think logically and to solve mathematical problems.
That's not the right one.
Row 4, ability to understand how objects are oriented in space. Pilots, astronauts, artists, navigators.
That sounds like the right one, so I'm going to select it with the space
New
bar.
term, movement.
And the visual spatial box pops into place as a type of intelligence in row 4, and a new choice appears, movement. So now if I continue through the table,
Row 5, ability to control one's body motions.
I'm in luck, that's the correct item,
New term, musical.
and so on. So I can move through the table with Tab and Shift-Tab, hearing each row, and then when I find the row where this item belongs, I press the space bar to select it, and the term pops into place, and I'm handed my next choice. And this continues until you finish the table and get a message indicating that you've succeeded. So this is a novel approach to drag and drop. Drag and drop obviously is extremely difficult to implement as it's normally presented for sighted people with a mouse to be used by people using a keyboard only, and especially people using a keyboard and a screen reader with no mouse access and no vision. It's very difficult to spatially define targets and move to them. And so instead, what this approach does is it rewrites that mouse activity into a keyboard-based activity where you can move through the choices, find the choice that you need, and the drag and drop itself is handled automatically, essentially. You don't have to do dragging and dropping, you simply select the right choice, and the activity can proceed that way. I think that's a good approach to drag and drop because there really isn't any way to make the actual original mouse-based movement accessible, and it would be really cumbersome to try. So instead, to replace it with something that's a fairly streamlined keyboard interface makes a lot of sense and can be done, I think, in a fairly consistent way through using widget templates.
So that is the second interactive example that I wanted to show you. And obviously there's lots more to come from Pearson and from MetroDigi, and I'll tell you more about that in a moment. I wanted to point you toward a whole bunch of resources. Obviously, a lot of this may also be included in the resources in the scientific graphics report on the diagram website. As Kyle mentioned, he's got a ton of resources listed there. A couple of top-line ones, obviously, is this project itself, the Interactive Scientific Graphics Recommended Practices for Verbal Description by Kyle Keane. And here again is that link, diagramcenter.org/accessible-dynamic-scientific-graphics.html. And if you're starting to write this down, you don't need to if you don't want to, because the slides and an accessible Word version of them are available on the diagram website. Another resource I wanted to call out to you that we just recently became aware of is a detailed technical guide by Brian Garaventa. He's the SSB BART staff member who helped to make these widgets accessible, and he also has his own website called WhatSock, W-H-A-T-S-O-C-K. And his training guide takes a really kind of rigorous approach to breaking down screen reader accessibility to show the different layers of interaction that need to occur and the different ways in which software you might be writing needs to talk to assistive technologies in order to ensure that the chain of information goes on and on. And then, those two are sets of information that are available right now out there on the web, and you can use them immediately. I also want to tell you about some resources that are coming up soon, but that aren't everything you need today. One of those is a set of guidelines that NCAM is working on as part of the Diagram Center, and they're guidelines on multimedia and interactive activities. So they take a little bit of what Kyle did in detailing what kinds of messages interactive graphics need to be conveying. And then these guidelines go a bit more into how you might embed some of those messages in different kinds of technologies. So as many technologies as we can figure out, we'll be publishing guidelines for, and those should be available from the Diagram Center website in the spring. Another piece of work related to this is the IDPF, which is the International Digital Publishing Forum. They have an EPUB widget framework, and this work is growing out of an effort called EduPub, which is a standards collaboration between three big standards agencies to solve problems in educational e-publications. So EPUB is an existing digital book standard, and EduPub is looking at ways to enhance EPUB to make sure that it serves the needs of educational audiences, including the huge need in education for accessible materials. So as part of that effort, there's a widget framework, and the folks from MetroDigi have donated the first 6 widgets. So these are now open source general widgets of sort of some of the most common types. And those widgets are available for everyone in GitHub at github.com/idpf/widgets. And the good news is that over the coming months, those widgets will be updated to be more accessible. So the first versions that were posted were not the accessible versions, but over time, that widget repository will be updated, and the accessible versions of widgets will be landing in there, and those will be available for anyone to use as a template and as a flexible start place for accessible widgets. Another terrific piece of work is the PhET library of interactive widgets. PhET, I think, used to stand for Physics Education Technology, but they've gone far beyond physics now. And if you visit phet.colorado.edu, they've got a large library of interactive educational materials for STEM. They are embarking on an effort to make those widgets accessible, and it's going to be obviously a process of learning and research for them, as well as development. So I can't tell you when those will be ready, but I do know that those efforts are underway. And now I think we're ready to discuss more questions from all of you. So if there are questions already in the chat box, Julie will lead us through those now. And if you've got questions that have come up, please do go ahead and add them in the chat box.
Thank you, Madeleine. That was really interesting. We do have a question. Somebody says, I'm stunned with amazement over this accessible drag and drop. Do I understand correctly that spacebar activates the drag and drop?
This is Madeleine, and yes, that's right. I tabbed through to move from place to place in the table, and then I used the spacebar as if each of the, I think essentially it converts each of those table cells into a button, and then that button can be selected. Excuse me. So you can select it with the spacebar as you would, the same as the next and previous buttons.
Thank you, Madeleine. So while maybe people are thinking of their questions, there was one back for Kyle, and there's been some discussion in the chat about it, but I'm going to ask it so everybody has the benefit. Somebody asked, Kyle, how do you create the SVG graphic? What's the process?
Yeah, for this working example that's on the web, it is manually coded. So I open up a text editor and type in an SVG bar chart, which is a pretty simple 2 rectangles and a rectangle around it to make it look like a bar chart. You can, and then you can embed that SVG directly into HTML, which is, from my understanding, the best practices for making accessible images on the web is using SVG markup. You can also use other software to produce an SVG, and then you just have to look through the SVG source file to find the parameter that you would want your interactive control to that parameter. I use inner HTML every time the slider changes value to change the value of the SVG parameter that displays that graphic part, that like bar of the bar chart or something like that.
Okay, that's great. And all of this code is open source, right?
It is all totally open. It is right there on the web. You can either click View Source, and you will have access to all the JavaScript, HTML, the minor bit of CSS, and the SVG. Everything is right there on the web. There's nothing hidden. You can also, there is a link on the main research page of this project that brings you just to the source code. So without any of the styling of the diagram website, you can see just the HTML and JavaScript, like a streamlined version of the code. And please play with it, hack it, make it your own, share it with people. I want this to become part of a conversation. Criticize it, that's fine. Like, criticize it and make it better, please.
That's awesome. Thank you, Kyle. Madeleine, back to you. Just a follow-up question about the drag and drop. Just to check understanding, you first turn the table into a series of buttons while it's being interacted with, and then when you leave the table, the button function returns to normal. Is that how it works?
I apologize. I cannot enlighten you on the technical specifics of the interactives that I demonstrated because I wasn't involved in the development of them. It seems like, to me, that's what happened, yes, because if you go back to review the table, if you're done with the activity and you say that you want to go back to just reading the table in a normal way, it does return to being a normal table.
Okay. And another question. What format are the accessible textbook examples in? Are they HTML? Are they on the web?
They will be available from the web. I can't tell you exactly what the code is, and I apologize again because I'm demonstrating them, but I'm not the developer. If anybody's available who wants to answer in the chat, who knows more about the programming details behind them, you can put that in the chat and we can share that with the group. However, what I will say is that they will be available, I think, later this year, and it may be that at that time there'll be more information.
Okay, great. We'll look and see if anybody's able to answer that. In the meantime,
I can answer
another
one question. I see that someone's asking if the drag and drop is compatible with any browser. And my understanding is that it was tested with a number of browsers and screen readers on both Windows and Mac. I used it on a Mac, and it worked great, and I know it's been tested on Windows as well. So I can't promise you any browser, but I do know that it works with a number of browsers.
Okay, great. All right, and I think that concludes the questions. And if any more occur to you, please feel free to write to us at info@diagramcenter.org, and I'll be sure to get questions to the right person. I really want to thank you for joining us today. I have some more resources here for you in addition to the ones that Kyle and Madeleine have shared with you. If you want to see other Diagram Center research that's been going on, including about 3D printing in the classroom and other things, I have a link here for you, diagramcenter.org/research.html. You can follow us on Twitter. You can email us, as I said. The Diagram Center work is part of a larger initiative we call Born Accessible. We believe if a resource is born digital, by gosh, it ought to be born accessible. So we have a web page here with resources about that, and of course a link to other things that are going on. We have a library of webinars. If you enjoyed this webinar, please know we do these quarterly. We have a library of 8 of them here, and this one will be posted, as I said, next week. And the slides are available right now. So with that, I want to thank you all very much for attending, and we hope to see you next time. Bye, everybody.